So today we're going to talk about some different sampling methods, specifically random sampling methods. We'll talk about how to distinguish between the different types and describe how to take a random sample in detail and in context of a specific situation. So first is just to recap, randomness is talking about without conscious decision. So all statistical sampling decides have in common the idea that chance, not human choice, is used to select the samples. And that's important because our brains and our conscious decisions have bias in them even when we're trying not to. So the idea of randomization is to let chance do the choosing. Randomization protects us against factors that we know are in the data and factors that we are not even aware of. One of our old textbooks used the example of a big pot of soup. So if you have like a big pot of like vegetable soup, and you want to make sure that every spoonful or every bowlful of that soup that comes from that big pot looks like the entire pot, that it has a little bit of everything that's in the pot. So if I stir it, which is the idea of randomization, I have a better chance that every single bowlful, every single spoonful will taste and be like the entire pot. So that protects us against factors that I know are in the data. So I know that I put salt in there and I want to make sure that salt gets spread throughout so that every bowlful is similarly salty and it's same as what the entire soup tastes like. But it also protects us against factors that we're not even aware of. So for example, if our friend, while we weren't looking, threw some peas in there, us stirring it up or randomizing will kind of mix that around too and make sure that each bowlful looks similar in terms of how many peas it has. So randomizing minimizes bias in the sampling process. It makes sure that on average, our sample looks like our population, and that's really what we want. So the first way that we can take a random sample is with what we call a simple random sample, or SRS. So this is our most basic and fundamental type of sampling. And our basic description is that we number every subject or every individual in our entire population, and then we'll take a random sample of those numbers. And that could be done a variety of ways. We can use a random number generator like on Google or in our calculators. We can put all of the numbers for the entire population on little slips of paper and put them in a hat and stir it around and pick some out. We could use a dice if we had a dice that had enough sides on it. We could use flip a coin if we only had two options. We could use a random digit table, but there's lots of ways. I would pick some of those numbers, and then whichever subjects had their numbers picked would be our sample. Some advantages of this is that every individual has an equal chance of being selected. Another thing that's true, and this is not necessarily like an advantage, it's just something that is only true of a simple random sample, which is that every set of N individuals has an equal chance of being selected. So any group, any possible combination of people, if I have a population that's 100 people in it, and I'm trying to pick 10 of them, with a simple random sample, any combination of 10 people has the same exact chance of being picked. So picking the first 10 people in the line is just as likely as picking every 10th person, which is just as likely as picking the last 10 in the line. Every combination of 10 people has the same chance of being picked. Again, that's not always an advantage, and we'll kind of talk about that with some of the other sampling methods, but it is something that is only true about a simple random sample. Some disadvantages of a simple random sample is that a smaller sample may not be representative. If we have a really big population and a really small sample, it's certainly possible that our small simple random sample may not look or be representative of the entire population. We could just get a bad or biased random sample just by chance because we're taking such a small sample from a large population. And then another thing to keep in mind is that sometimes it's either really difficult or almost impossible to number the entire population. So for that case, and that's usually the reason we don't always want to use a simple random sample, we've got some other options. So another option we have is called stratified. Now this one isn't really going to make things easier, it's actually going to feel like it makes things harder, but what this is good for is when we have facts or variables about our population that we know are going to impact their answers to this survey. So the way we do stratified sample is to divide our population into strata, which would be homogeneous layers or subpopulations, things like genders, male, female, non-binary, other, etc. Or it may be at a high school, if we're talking about high school students, the strata might be grade level, 9th, 10th, 11th, 12th. If we're talking about animals, I may divide it into types of animals: dogs, cats, birds, hamsters, etc. So I'm dividing them into groups based on some similar characteristic. Then what I'm going to do, oops, I had some examples there, is I'm going to take a simple random sample from each strata. So if I'm talking about gender, I'm going to take a sample of some males and a random sample of some females and a random sample of non-binary and whatever. So I'm taking a simple random sample from each group, and what that does is that makes sure that each group is represented. Right? So advantages would be that it ensures, it guarantees that every group is represented in the sample. And that could be really important for our survey. So if we feel like 9th graders are going to feel differently about something than 12th graders, then we would want to take a stratified sample so that we guarantee we have some of each grade level in our sample. A simple random sample does not guarantee that. I could very easily pick a simple random sample with all 9th graders in it because every possible combination of people has the same chance of being in our sample. Disadvantages of stratified, honestly, it's just that I didn't even write this one, but it can take longer. It's longer to set up, and now you have a whole bunch of different groups that you have to deal with. And sometimes it's not obvious what variable to stratify by. So on the lab that you guys did with the random rectangles, we stratified by size, which made a whole lot of sense because our goal was, what's the average size of these rectangles? But it's not always obvious or easy or doable to stratify by the exact variable that you're trying to find out about. Sometimes it's hard to know how to divide up your groups in a way that would be helpful in estimating the thing you're trying to estimate. So example of stratified, if we are polling students about off-campus lunch privileges, but we think that different grade levels may have different opinions. So we make sure that we have some of each grade level in our sample, and that kind of fixes that issue. Another type of sampling, which also involves grouping, is called cluster sampling. So in a cluster sample, we are also dividing into groups, but this time we're just really doing it by, it's usually by what's natural, like natural groups that exist within our population already, but we're kind of just dividing it into smaller little sections. Now, in theory, each cluster by itself should be somewhat representative of our entire population. So we're kind of dividing it into like little mini populations. And then what we would do is we would randomly select one, or maybe 2 or 3 or 4 of the clusters and use the entire cluster or clusters that we picked as our sample. So this time, stratified, we're taking a sample from each strata because we want to make sure that each strata is represented. With cluster, we're picking an entire cluster, or maybe 2 or 3 clusters, as our sample and ignoring the rest completely. We're not ignoring, but we're just not picking them. This is really useful, and it just makes sampling easier. When we have a really big population that already has natural clusters that exist, like city blocks or pages in a phone book or whatever, cluster can be something that just makes the sampling process easier. It also makes it to where we don't have to number as many things and take as many random samples. So it just kind of makes things a little bit easier. Now, some disadvantages, and you may have thought of this, right? Our selected clusters may not be representative of the population. So again, cluster sampling works best when we have like these clusters that are in and of themselves representative of the population. And it's not always easy to do. It's not always the natural clusters that exist. In your random sampling, your random rectangles lab or activity, you may have seen that some of the clusters were not super representative of the whole group. There were a couple clusters that had a whole bunch of small rectangles and maybe only 1 or 2 big ones. So those clusters were not representative, and that's the cluster that you picked, and you ended up with a really small average. So an example of cluster, and this goes back to phone book, so you have to kind of know what a phone book is. But if we wanted to take a random sample of people listed in the phone book, we could choose randomly a page number and then call every person listed on that page. So that way I'm not having to number every single person in the phone book. I'm only having to number the pages, which are already numbered, and then I pick a random page, use that entire page. Another type of sampling is called systematic sampling. So systematic sampling means we randomly select a starting point. So if I have 100 people, I could randomly select a number between 1 and 10, and whatever number I pick, that's the first person in my sample. And then from there, we're going to do every 10th, or maybe every 20th, or every 30th subject thereafter. So my first person is the random long picked, is maybe the 7th, and then I'll do every 10th after that. So 7, 17, 27, 37, 47, etc. So systematic sampling is really useful when we have an unknown population size or no realistic way to assign the subjects a number. It also works really well for if we have a situation where we want to make sure and have representation like throughout a time period. This is a really good way to do that because it kind of guarantees that we're spreading out our sample throughout the entire population or throughout an entire time period. Maybe if we have people in a line, we randomly pick the first person and then do every 25th person after that. And that kind of guarantees that we're getting people throughout the entire line instead of just a whole bunch of people up front, which is of course possible with a simple random sample. Disadvantages, and this is kind of questionable, but once you pick that first subject, you're really not giving every subject a chance of being picked. Once you pick 7 as your first random number, number 16 or number 25, they no longer have a chance. So it's a little questionable in some situations, but it does make things easier in certain situations where it's hard to number everybody, or we want to make sure that we're getting throughout an entire time period. So example, we want to pull people who go to the mall on Saturdays. I don't know how many people are going to come to the mall on Saturday. I have no way of numbering them, or realistic way of numbering them. So what I could do is I could choose a random number between 1 and 10 to select the first person I talk to who comes in the door, and then I might talk to every 10th person after that. That might be a little bit hard because as you're talking to one person, more people are coming in, and are you counting them? Do you have a partner? What's going on? But you get the idea. This way I'm making sure that I'm talking to people throughout the day, and it kind of fixes that problem of not really truly knowing how many people are in that population. Our last method of sampling is called multi-stage, and this is pretty much what it sounds like. It means that randomness is involved in more than one stage. So this is used when our population is very, very large, like the entire United States people. I said that weird. But it makes it easier to break down our population into more manageable chunks, and it gives us a little bit more representation as well. We want to be careful not to confuse it with cluster. It is often confused with cluster by students, and that's really because cluster is usually one of the stages in a multi-stage. It probably is the first stage. So just to go throw back to our cluster example with the phone book, multi-stage would be I choose a random page from a phone book, and then I choose 10 random people from that page. Remember, cluster is I choose a random page and then use everybody on that page as my sample. But multi-stage means I'm adding another step or stage of randomness. I choose a random page and I pick 10 people from that page, right? So that becomes multi-stage because I have an extra stage of randomness. So now what we're going to look at is how to describe taking a random sample, which is really important to know how to do for a simple random sample. That comes up a lot on free response questions on the AP exam, but you should also be familiar with how to describe a stratified or a cluster random sample as well. So I'm going to show you a simple random sample. Stratified and cluster, you just kind of have a little bit of pre-steps to do and slight adjustments to make, but I'm going to show you in detail what it looks like to describe a simple random sample. So, for example, if you were asked to describe how to select a simple random sample of 5 students from a group of 27. So the first thing you're going to talk about or describe, and again, this is you writing out steps in full detail, is you would say to assign each student a unique number. We do want to say the word unique. Excuse me, you do want to say the word unique because we want to make sure it's very clear that every student is getting a different number. Now I'm using 1 to 27. You could technically tell them to use whatever numbers you wanted, but obviously 1 to 27 makes sense. But you do need to be descriptive or specific and say what numbers to assign. Then we're going to say what method of randomization to use. So I'm going to say we're going to use a random number generator. RNG just stands for random number generator, and it is okay to use that abbreviation on the AP exam. So use a random number generator on a calculator or a computer. You don't have to write on a calculator computer, but you can, to generate 5 unique numbers from that range. Repeated numbers will be ignored. So I'm picking 5 numbers from that range. So again, I do need to use the word unique, or I can say that I'm going to ignore repeated numbers. One or the other of those is fine, but one or the other of them has to be there. Again, we want to make sure that it's clear we are picking 5 different numbers representing 5 different students. In some situations, it might be okay to pick the same number twice, and we want to make it clear here that we want 5 different numbers. So unique or ignore repeats needs to be in that step. And then our last thing we want to say is, what happens then? We want to give it some context in this situation. So I would then say the 5 students whose numbers were chosen will take the survey, or will win $100, or whatever it is that they're going to do in this situation that's been described for you in the problem. We always want to be very, very specific and very in context of the problem. So specific means give me exact numbers that you're numbering everybody. Tell me exactly how I'm going to pick my random numbers, like with a random number generator, etc. And then say exactly in context what those chosen people or individuals will do once their numbers have been selected. Another way we can do it, I just want to show you a different method besides random number generator that you could potentially use. And that is with a hat. So I'm going to first start by saying assign each student a unique number from 1 to 27. Still doing that. And then I might say write the numbers 1 to 27 on slips of paper, put them into a hat, stir the slips to mix them. So the stirring of the slips to mix them is kind of what makes it random. If you don't mix them, then technically you could be picking out the numbers that you put in last. So stirring the slips makes it random. So that is important. Without looking, draw 5 slips of paper from the hat without replacement, right? So when I pull a slip of paper out and that's my first number, I'm not going to put that number back. Again, that gives us 5 unique numbers that we're choosing from the hat. We can't get the same one twice, so that is important. Without replacement is important. And then I would say the 5 students whose numbers were chosen will. Okay, notice I still went with numbering here, but it would be perfectly fine for you to say, put each student's name, full name, on slips of paper and put all of those slips of paper in a hat. And then the 5 students whose names were chosen will. That's totally fine because it's still getting around the process. But the idea is that you want it to be very, very, very specific and very in context. The specificity is always what people or students in my past years of teaching will kind of leave out. This is a very specific thing that we're describing for someone. We want to make it so that any 2 people who read your instructions and followed them would be doing it the same exact way. So we are being very, very, very thorough in describing this, taking a random sample. And that's it. That's how we describe taking a random sample. Bye guys. See you next time.